On this episode of Global Topic, I'll have a conversation with Dr. Steve Ricci, Partner and Chief Technology Officer at 10X Engineered Materials. Dr. Ricci and I will have a conversation on the topic of engineered blast media, SUPEROXALLOY. Welcome to Global Topic, the go-to series for the global corrosion and protective coatings industries, exclusively here on YouTube. In this series, you'll find technical content, information, and the latest industry news and events. And now for our interview. Hey, Dr. Ricci, welcome to Global Topic.
Hey, Jim. Thanks for having me. I'm excited about this.
Hey, if you could do a favor, if you could go through, talk about your background, and also provide some overview regarding 10X Engineered Materials.
Okay, so I have a PhD in chemical engineering, and I worked in at Battelle Memorial Institute in Columbus, Ohio, for about 22 years. And what I did there was a lot of fluid mechanics, a lot of material science, just a wide variety of things. And I finished my career developing clean tech, new technologies in the clean energy space. 2015, I left there and I joined my partners. And what we've done here is we've identified a material out there that is available, and we saw its potential as a blasting abrasive. And we developed a process to make a new blasting abrasive over the past several years. And we went commercial with it. We finished our plant and started producing in July of 2019. And we have been in business for the past, 18 or 19 months.
Steve, for those watching this episode who have limited or no knowledge on engineered blast media, could you please provide a basic overview on what this advanced material is?
Yes. A superoxalloy is what we call it. It is an alloy of minerals that's formulated and processed to be extra strong and have superior properties compared with conventional mineral materials. Superoxalloy is a composite of the terms alloy, superalloy, and oxide, which we created this new scientific term to help explain succinctly what this material is and what it can do. Because, and right now, if you look at the overall idea of making an abrasive like this, there's a need for innovation in abrasives right now. The regulations around beryllium and free silica have been tightened considerably by a factor of 10 over the past several years. And so there's a need for a material that doesn't contain those hazardous substances and produces less dust to prevent the risks associated with exposure to those hazardous chemicals. And we're living in a world right this minute that markets are depressed by COVID. Coal burning power generation is in decline. Renewables are starting to outpace the fossil industry. So there's just a lot of pressure in the industries that use blast abrasives. And there's a need. Everybody is looking for ways to do more with less, to do more with less cost. And superoxalloy abrasives provide all of this. It's very efficient, very cost effective, and it virtually eliminates these newly tightened risks around free silica and beryllium. But in essence, a superoxalloy, and I'll go into more as we go along, but it makes a very strong particle and offers all kinds of advantages.
Over the past year, I've had the opportunity, both on LinkedIn, and also through industry reports, to really look into what 10X abrasives, what you were doing. And I have to say, I was very impressed with the engineering that went into the product development, and importantly, the focus on what industries, customers, and the safety standards that are required for blast media. Could you talk on the technical aspects of the SUPEROXALLOY product?
Yes. In short, the material is made from a mineral melt and then rapidly cooled back into a solid. And this does several important things. First, melting erases any crystalline content that there might have been in the minerals to begin with. You can formulate the abrasives to be safe, to not contain what you don't want them to contain. But the rapid cooling, it creates an amorphous particle structure. It's uniformly strong throughout. There aren't any pores or weak planes in the material that might cause a particle to fracture on impact with a surface. And it's also tempered. And as most people know, a tempered material is many times stronger than a normal material. Tempered glass, for example, is stronger than regular glass. So if you take that property and you translate that into blasting, blasting is an energy transfer process. We invest in compressors, pressure pots, hoses, nozzles, all with the objective of accelerating particles to a very high speed. And now what we want to do is deliver that particle energy to a surface as efficiently as we can. If a particle breaks on impact with a surface, then much of the energy that particle had is used up in the process of breaking, and less is actually delivered to the surface where it's needed. And this is what enables superoxalloys to blast faster than other abrasives, including abrasives that are harder and sharper and on their apparent properties should be superior. A material that doesn't break when it hits a surface and just bounces off delivers all of that energy to the surface. So it does more work faster, and it's more effective on more difficult coatings especially. That's one. It makes them faster. The second is it reduces the amount of abrasive needed to complete a job. So if you have two pots of abrasive, and one is filled with, say, a certain grit size of an abrasive that would tend to break when it hits the surface, and you have another pot of the same grit size with an abrasive with stronger particles in it, they're going to have about the same number of particles. So if the stronger abrasive accomplishes more work per particle, then you will need less of it per square foot to complete the job. So it does that. And then finally, and this is something we could talk about all day, and I'll be succinct. When a particle breaks on impact with a surface, it's like mud sticking to a wall. The abrasive particle hits, it pulverizes, and smears into the surface. And that's called an embedment. An embedment does really two things. It accelerates corrosion, and it reduces coating bonding strength and coating quality. And our superoxalloy abrasive doesn't do this. The vast majority of the particles just bounce off the surface, and you can reuse them if you can reclaim them. If you take the impacts of embedment go far beyond, certainly they create inefficiencies in the blast and paint operation. They may have to clean the surface, reblast the surface. If it flash rusts, they certainly have to rework certain surfaces before they paint them, or scheduling gets complicated because you have to come in and prime before you continue with blasting. And so you constantly have your blasters in there and then your painters in there, and you have to, if there's no embedment, you don't have to do that. And I can give you an example. And the reason that embedment promotes rust bloom is because there are water-soluble salts and sometimes iron-based compounds left behind with those embedded particles, and they accelerate corrosion. Bare metal corrodes very slowly. And so what superoxalloy does is leaves a bare metal surface that is left to its natural rate of corrosion, which is very slow. We blasted a ship recently to SP6 finish, and it had to sit before it was coated for various reasons on the job. And after 3 weeks, it was still SP6. They could coat it. So if you take into the costs into account the costs to the blaster and to the asset owner, and some of these assets are huge: pipelines, bridges, tanks. Their coatings perform better. The maintenance cycles are longer, so they don't have to recoat as often, and it's out of service for less time with a more efficient abrasive. So there's just a lot of advantages to having a strong particle, and we're demonstrating this over and over in the field.
So you just talked about and covered some of the different assets that are out in the field, structures out in the field, that this engineered blast media is used. So superoxalloy, what industries benefit from using this media related to surface preparation?
When we started in 2019, we went after the large scale, the contractor market, the maintenance market, with our kinetics product. And we've been able to demonstrate advantages both in dry blasting and in wet blasting on bridges, tanks, rail cars, the larger blast jobs with that product. But along the way, we had interested prospective customers in more specialized markets like original equipment manufacturing, powder coaters, who tend to use more exotic, more expensive abrasives like aluminum oxide, silicon carbide, and some ceramics. But what we found was superoxalloy, even though it's softer, we're about a 7.5 on the Mohs scale, and these other abrasives are anywhere from 8 to 9 plus, we were outperforming them. And it's that energy delivery issue that I just talked about. If you might have a harder particle that has a greater potential to do the job, but if those particles aren't delivering everything they've got, if they break, and they do, because those abrasives form dust, you can outperform them. And then what we're finding is our dust levels are way lower, far fewer particles are breaking, and that market is loving this product. So what we did was we created a new line of products that are finer than the kinetics fractions. Kinetics products go down to about 70 mesh in size, and our Epix products go all the way down to 200 mesh in size. And the powder coaters just love it. What they've found, often what they have to use is like a methylene chloride dip before blasting to make the coating able to be removed, or to bake it in an oven before removal of the coating. They don't have to do that. The Epix product just removes it without assistance, and they're far more productive, and they're getting better performance out of their powder coated surfaces. So we are now in all the markets. We haven't branched out of blasting yet, but we will over time test in bonded products and other products. We haven't done that yet.
So, you did cover some aspects of, return on investment, or ROI, that with superoxalloy, how does that compare? How does that product compare with traditional abrasive blast materials related to ROI?
If you, like we talked before, if you take into account the economics of both the blast and paint operation and that of the asset and its owner, it's an open and shut case. But let's just draw a box around blasting. In the market, there are a lot of users out there who focus in on the cost per pound of the abrasive. And what we're seeing is that even if our abrasive costs 2 or 3 times another abrasive in price or cost per pound, we can still considerably reduce the cost per square foot, which is what matters. If you use less material, then all of the costs to the blaster that are associated with the mass of the abrasive, the amount of abrasive you use, go down. And that would include the cost, the abrasive cost, which is per pound. Your cleanup costs go down. Your disposal costs go down. And there are others. If you blast faster, then all the time-based costs are decreased. And those include labor, equipment, fuel to run your compressor, and wear on consume, on nozzles, hoses is also reduced. So those costs go down. And if you take all of this, which all goes into the economics of a blast operation, the cost per square foot will be considerably lower, even though the abrasive is twice as expensive per pound. We have a customer who was using a competing mineral abrasive, and they went through the process of sort of optimizing their systems to use superoxalloy abrasives. This was a shipyard. And they have increased their blasting speed by 40% and decreased their consumption by 85%. What used to take them a truckload now only takes 2 or 3 supersets. And so their cost per square foot have plummeted, and they are very pleased with their returns. We have a lot of customers. That's just one example.
That's very impressive ROI. Steve, what a great conversation we're having. In closing out this episode, is there anything that we didn't talk about that you would want to leave with the viewers?
So, yes, we've spent most of our time here talking about performance and economics, and that's what matters. That matters. Obviously, it's extremely important. But we didn't cover safety. I'd like to talk about safety. If there's anything that we want our customers and the marketplace to know, is that our abrasives are verifiably safe. Exposure is really a mathematical product of total dust concentration and the level of hazardous material in the abrasive. If total dust is lower, which it is, significantly lower when using superoxalloy abrasives, then that lowers your risk of exposure, and it also increases the visibility for the workers, which is a safety issue. Free silica has never been detected using NIOSH 7500 at a reporting limit of 0.1% in our abrasives. It's never been detected. Beryllium, using EPA 1311 at a reporting limit of 4 parts per million, has never been detected in an analysis of our material. And the last thing, and also very important, is that the TCLP is clean. You can dispose of, you can leave, as long as the abrasive is not contaminated with other hazardous materials from the environment, the blasting environment, you can leave it on the ground. You can dispose of it by conventional methods, and you can even dispose of it in water if, for whatever reason, that might be required without any risk of harm to the environment. It was the first thing we did in development, was to analyze for safety and environmental hazards because we didn't want to develop a product that could cause harm. So that's the last point I want to make. I want your listeners to know that these abrasives are safe.
Perfect. That's a very good closing, comment on all what you just covered. So for the viewers, what I'll do is I will have links to the 10X Abrasives website, also information that actually specifically goes to products like SUPEROXALLOY and other products and everything like that. Steve, I appreciate the opportunity to have a conversation with you today.
I appreciate the opportunity to have this conversation with you. Thank you very much.
No problem. Hey, have a great day.
Okay, you too.